We have a tricky one. Let's do it. All right. This series is 1 over e plus 2 over e squared plus 3 over e cubed. You can see the pattern. The next one will be 4 over e to the fourth, 5 over e to the fifth. So knowing that this is the first term, this is where n equals 1, and this is where n equals 2, and this is where n equals 3. Then if I wanted the nth term, then I would be dealing with n over e to the n, n over e to the n, 3 over 3 e to the 3, 4 over e to the 4, n over e to the n. Got it. Okay, so, whoo, almost dropped a marker. This is the sum from 1 to infinity of n over e to the n. Okay, sounds good. Let's keep moving. I want to know if this converges. Don't know. Let's find out. I don't know what it converges to if it does converge, but I do want to know if it converges or not. That's the question right now. So let's write, using the integral test, its function equivalent, which would be x over e to the x, and then ask ourselves 3 questions. Question number 1, is this positive? Yes. Regardless of what value you plug in, you're going to get a positive number. I say regardless of what value you plug in because we're only dealing with positive n values, positive x values. Okay, you start playing with the negative numbers, no, just no. But that's not in our domain, so to speak. So positive, yes. Decreasing, yeah, because the exponent in the denominator is increasing, so the denominator is getting bigger, the numerator is getting bigger, but not of the same magnitude. So the denominator is exponential, the numerator is linear. Exponential is higher magnitude than linear. Positive, yes. Decreasing, yes. Continuous, yes. No discontinuities in that. You'll never ever have a denominator equal to 0 on that. Good luck trying, not going to happen. So let's use the integral test, and here we go. The integral from 1 to infinity of x over e to the x dx. I don't care what this is, I just care if I get an answer, then it converges, this converges, so that converges, and we'll say it worked. Or if this doesn't have an answer, we'll say it didn't work. So let's move on. First of all, can't go to infinity, that's why we have limits. That is the worst I've ever spelled L-I-M, but we're going to go with it. B approaches infinity of the integral from 1 to b of, all right, x over e to the x. That's going to be a little sloppy. Let's go ahead and rewrite it. X e to the negative x. Doesn't look cleaner, but trust me, it's going to help. And that's what we're dealing with. If you want to leave it like this, go for it, but good luck. So as I look at this and realize that I need to integrate this, I'm dealing with basically 2 things multiplied together. My first guess is to use u substitution. Very quickly, I'm going to show you how this doesn't work. If I said, oh, u is the exponent, then the derivative of that would be -1 du, the x, I mean. And then how are you going to get your x out of this thing? Yeah, good luck. It's just not going to happen. Not going to work. So this is going to be, I love it, integration by parts. So this goes back to some other stuff that we have done, older stuff that we've done, where we had, you don't have to write this, the integral of u dv equals uv minus the integral of v du. Good to know. You can use that. I'm not. I'm going to go with the other shortcut to this, not a shortcut, but I'm going to go with the other shortcut where we make a table. So just over here on the side, you can do that because one of the factors is linear, so it's going to approach 0 really quick as you keep taking derivatives. It's going to just get towards 0 super fast. So here we go. This is going to look familiar when I start writing it. So sines, and then u, and then the derivative of that, and then we keep going, and then dv, and then v, and then we keep going. Here we go. Go marker, go. Don't run out of ink now. Positive, negative, positive. I'm going to need 3 rows because I've done this one and I know that. X is u. Trust me, it is. You need u to be the thing that will eventually approach 0. So the derivative of that is 1, the derivative of that is 0. Good. Mission accomplished. E to the negative x. The integral of e to the negative x is negative e to the negative x because the derivative of that, chain rule, would take you back here. The integral of that is there. Okay, good to know. So we will have positive x times negative e to the negative x, negative 1 times e to the negative x. Let's do it. Let's write it. So this is equal to the limit. Written much neater, but you can't see because I'm in the way. There we go. The limit as b approaches infinity of, we have just taken the antiderivative. This is going to go from 1 to b, and we're going to have a mess in here, and that mess is this. It's an antiderivative. So positive x times negative, well, so it's negative, negative x e to the negative x. Wrote the wrong thing. Start the whole video over. Negative x e to the negative x, and then minus 1 e to the negative x, so minus e to the negative x. Okay? Personal opinion, as I step back into the camera. Personal opinion, I think it would be good for us to go ahead and rearrange it again, put the exponents that are negative in the denominator, fix that, and it's going to make it easier to look at and really deal with. So limit as b approaches infinity of negative x over e to the x minus 1 over e to the x from 1 to b. And we'll plug some things in, we'll figure it out. Now, let's not lose track of what we're doing. In the process of all of this, we had to detour and pull out some old stuff and rearrange things. I just want to know, do I get an answer other than infinity or negative infinity? Like, does this converge? If so, this converges. If not, it doesn't. Okay? Let's keep going. I don't know why I made that face. Like, I don't know. All right. The limit as b approaches infinity of negative b over e to the b minus 1 over e to the b minus, I'm going to get tricky with your signs, be careful. We're going to subtract this, which means I'm going to have plus, so minus that negative, 1 goes here, and then e to the 1, and then I would, all right, here we go. It's going to be confusing. I would subtract, but I am subtracting this entire thing, so it's plus again, 1 over e. Yep, am I right? Yeah? I hesitate? Yeah? Yeah, I'm right. Okay, I was looking at the work I'd done earlier. I'd hate to do this whole thing and be like, man, I messed up. Do the whole video over. We're 7 minutes in. All right, let's keep moving. As b approaches infinity, I just want to know what happens to each term. As b approaches infinity, I have negative b over e to the b. Who's more powerful, numerator or denominator? Denominator. Therefore, this is 0. Okay. B approaches infinity. 1 over e to the infinity, that's pretty much 0. Plus 1 over e plus 1 over e. That would make it 2 over e. So I have 2 over e. Am I glad that it's 2 over e? I don't care. But I do care that it converged. So therefore, without writing the lengthy explanation I did on the last one, here's the deal. Because the function equivalent was positive, decreasing, continuous, I was able to use the integral test for convergence. And because the integral converged, this also converged. Let me condense all that down to just a few words. Because the integral converged, converges, if you want to change the tense of it, converges, then the series converges. I'm going to write the series. The series which we had going from 1 to infinity of n over e to the n also converges. Done.